welcome to data structure. The next topic is the implementation of the topological sort. As we discussed about the topological sort in the previous video, now we try to execute the topological sort with some example. Please let's consider the topological graph for the topological sort. Now here we consider the 5 vertices with its connectivity between the rest of the vertices. So here we have taken the directed acyclic graph that the 5 different vertices are somewhere connected with another vertices. Now we have a look on the algorithm of the topological sort. According to the topological sort, the first task is to calculate the in degree of vertices. So in degree, as we know that the incoming edge toward the particular vertex, and out degree is nothing, the number of edge going away from the particular vertex. So the first point is to calculate the in degree of every vertices in the graph. From that, find the least in degree vertex. In some cases, the two different vertices will be having the same value. According to that, you select any one vertex and continue the step number 3. For our convenience, we go in an alphabetical order or in the numerical order. Based on the vertex name, either we go in the ascending order in alphabetical way or in the numerical way. So the first point is to calculate the in degree of vertex. The second one is to determine the least in degree vertex out of all the vertices, which is having the least in degree vertex, maybe 0 or 1. It depends on the selection of your graph. The third step is to remove that least in degree along with its vertex. So here a particular one single vertex will be removed along with its edges, and continue the above 2 steps until all the vertices are removed. Whenever we remove the element or the vertex, please add that vertex in your sorting list. So finally we will be having the sorted list, that nothing your topological sort. So please consider the graph, the 5 different vertices. The first target is to calculate the in degree vertex of everything in the graph. So may calculate the in degree. The first point is to calculate the in degree. According to V1, the in degree is 0. For V2 it is 1, and for V3 it is 2, and for V3 it is 2, and for V4 it is 2, and for V5 it is 2. So out of this we will be selecting the least in degree vertex, that's nothing your V1. So here the V1 will be removed along with its edges. So you will be having the updated graph. So the vertex V1 will be added in your sorted list and the edges will be removed from its graph. So finally we have the intermediate vertex V2, V3, V4, V5. Now calculate the in degree vertex of the available vertices. So V2, no connectivity between, so that the in degree of V2 will be 0, and V3 it is 1, V4 it is 1, and for V5 it is 2. Now we have the 4 vertices. Out of the 4, which is having the least vertex, that's nothing, V2. So the third iteration, V2 will be removed along with its edges. So we will be having the updated vertices V3, V4, V5. Now calculate the in degree of vertices V3. It's nothing, 1, V4 it is 0, and for V5 it is 1. Out of the 3, which is having the least vertex, that is V4. So remove that V4 along with its edges. So we will be having 2 disconnected graph, one V3 and another one V5. Now calculate the in degree of the available 2 vertices V3 and V5, both will be having the in degree 0. So it's your choice is to prefer V3 to remove or V5 to remove. According to the scenario, we have the possible sorted list V1, V2, V4, V3 and V5, or else the another possibility V1, V2, V4, V5 and V3. This is the way to perform the topological chart. Thank you.